Hello and welcome to our demo. I'm Danny. I'm a second year graduating in 2026 and I study math.
I'm Aditya. I'm also second year graduating 2026, studying mathematics and computer science.
Hello, I'm Anton, also graduating 2026, and I'm studying computer science.
And my name is Rishi, graduating 2026 as well. I'm studying computer science with a minor in statistics.
Our project was a full data pipeline starting from raw market data with PCAPs, uploading it into OneTick, a high performance tick database, and querying it and messing around within Strategy Pseudo to backtest some trading strategies. So let's get into it.
In our first phase, we basically got raw gzip PCAP data from Data Bento. There's already existing functionality for IEX, and so what we did was add in functionality for CME, SIBO, NYSE, and NASDAQ. And since each exchange has its own protocols, we examined each exchange's PCAPs in Wireshark to write parsers accordingly and make sure we were able to parse each and every one of the messages.
After jumping more into the coders and taking a deeper look at CME, we discovered that there were a couple crucial message types that we had to look at, specifically 46, 47, 55, 56, and those concerned formats that included the MD instrument definitions and order book snapshot. Our initial approach to parsing this data was to build out a manual byte-by-byte parser, as we have done to other exchanges, but we realized that the nuances of the MDP 3.0 format would make this a challenge.
Yeah, so after experiencing some complications with the manual parser, we decided to go ahead and use the existing XML schemas provided by CME. So to do that, we utilized the usage of the SPE tool by RealLogic to extract the header files from the schema, and then we implemented that inside our parser logic to speed up the process and complete the parser. The next exchange we dived into was NYSE, and a complication we faced was the presence of the VLAN trailer, which would pack additional bytes at the end of the message. So after remedying this by looking through Wireshark and adjusting our increments, we were able to finish outputting the entire parsed CSV.
Right, and we updated our manual parser to include these extra bytes so that it's getting to the message type efficiently. And the NYSE parser laid following groundwork for our one-tick migration, which is building the price level update and trade files to ensure that we can easily normalize the data that we parsed out of our PCAPs and bring that into one-tick for further analysis.
Yep. So next we started the manual NASDAQ HPCAP decoder, in which we parsed and handled 22 various message types, each of which had their own length and field offsets, which required various parsing logic. So using some switch cases, we were able to extract the raw payload from each of the packets and inspect each message type and its corresponding data.
However, due to the complexities of NASDAQ's data, specifically in there being 22 different message types, each of which have varying lengths and offsets, we decided to investigate OneTick's native NASDAQ loader. However, we were facing difficulties in this both in terms of speed and correctness. However, efforts are still being made on the local PCAP decoder.
Finally, we looked at the SIBO PCAP decoder, which we attempted, though was ultimately abandoned a little bit later on. This was in part due to some of the meticulous byte level processing and some complexities within the nested block structure. So that's a future plan for us to investigate a little bit later on in the project.
Another big step for our project was the development of our universal parser, which allowed us to bring some of the parsers that we had written in Python before, like for NASDAQ and such, and bring them over to a more comprehensive modular C++ version, which had a powerful master parser class, which could be easily extended with new exchanges so that in the future, new exchanges would be easily added and we could build a powerful backend in order to ensure that the exchanges are parsed with speed, and as well as decoupling the code so that we can add multi-threading in the future.
The next step for us to do was to then migrate the CME data into OneTick using the native loader. We found success in this endeavor by first pre-processing the raw PCAPs using OneTick provided preprocessor. Then we would gzip the files and then send them off to the native loader. And while this did ensure correctness, we did see a need for an improvement in speed. So that could be future improvement that could work on.
Our next critical expansion to the previous group's work on OneTick was implementing a full-on Jupyter Notebook setup to allow for visualization and easy querying, as well as understanding how to fully build an order book from data that's loaded into OneTick. In order to do that, we used OneTick special order book creation function, and as a result, we see that if we run that for Microsoft, we can see the best bids and the best asks along with previous depth right here. You can also do standard pandas operations to clean the data. So here's the very same order book now for NVIDIA. And we took it a step further and decided to do a manual VWAP calculation. And it appears that the overall price of the VWAP seems to be going down throughout this 5-minute period. We also made a couple other graphs to track the bid-ask spread. As we can see, initially there's a lot of spread. Market has low liquidity, and as we go on, it decreases. And here's the overall order book depth for NVIDIA. As we can see, the NVIDIA order book slightly offer heavy. And we also tracked the volume imbalance over time time, as well as the market liquidity. And we also tracked how the order volumes accumulate for the bid and asks of NVIDIA as well. As you can see, they are slowly separating apart. Now, one of the coolest and most interesting features we've made is a full-on order book animation where we play that 5 minutes of NVIDIA data and show off how the bid and ask are working alongside each other. Here's that right now it's ask heavy.
Our next goal was to basically combine the existing IEX functionality in one tick with that of CME. As you can see here, we ran a series of queries. The first basically combined 2 time series from Apple into one query, which measures the prices and the size. The next query, where we actually merged both the IEX and CME databases. And since CME was so large, we ended up having to select only a subset of the ticks. As you can see, they're all ticks that have UDWZ future contracts. And so this is just a symbol of the CME ticks as well as the IEX ticks. And then we ended up running the simple query of selecting the tick if its price is $15 or $193.4. And as you can see, you have data from both CME and IEX showing up. So that just reflects a successful integration of both IEX and CME into one tick.
So the final phase of our project was the one tick to Strategy Studio connection and subsequent Strategy Studio strategy development. And so with this, we had a couple steps. So first, streamlining the connection between one tick and Strategy Studio, creating some sample trading algorithms in order to validate the pipeline's accuracy, implementing some error checking. The main focus in terms of the strategy development itself was to use a detailed reconstruction of the order book to visualize market depth and utilize things like trends, inconsistencies, imbalances in the order book, and less clear market microstructure patterns as we saw before. As such, the focus kind of fell on strategies that focus on order and overall market structure insights, and we made use of the granular data, obviously up to level 3 data. Future steps would be to obviously complete the pipeline, build a simulation environment, validate and backtest these algorithms to ultimately bridge the gap between the raw market data and actionable trading strategies, providing meaningful insights.
Completing this pipeline and combining data from multiple different exchanges provides a very unique and hopeful perspective on conducting complex algorithms and backtesting on market data. We're hoping in the future to add more exchanges and combine the NASDAQ, NYSE, and CBOE parsers and data. Also optimize latency, speed up the whole process, and incorporate some more advanced machine learning models to create some great trading strategies and make money.